This is Qt 5 Design Patterns Section 7. This section is all about templates. We're going to look at issues with QObjects and templates. We're going to look at pointers and templates along with the Qt template classes and how to use smart pointers inside of templates. If any section in this course frustrates you, it's going to be this section, because we're talking about generics, and generics gets very, very complex very quickly, and Qt adds to that complexity, unfortunately. So generics can be implemented in C++ using templates. You've probably done this thousands of times. We've got a very simple code example here where we have a templated function called add, and it does exactly what you think it does. It takes x and y, adds them together, and returns the value. Doesn't matter what type we give it, it will just try to do it. So our very rudimentary examples, we have an integer, we have a double, we have a string, 3 and 6, 3, blah, 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 and hello world, and it does exactly what you think it should do. Everything just works. The problem comes in, of course, when we try to add a QObject in here. We have our trusty little my class, and there's nothing special about this class. It just has a a constructor and a deconstructor in here. So we have created and destroyed. Got a little tongue-tied. And we're just going to add this in and see how this works. So we've got our include right there, and let's go ahead and just say my class M1 and my class M2, and of course my class M3 equals add, and we're going to say M1 and M2. Let's see what happens here. And before we even get very far, oh yep, it already knows there's a problem. So first thing we see, invalid operands to binary expression. Ooh, I know exactly what that is. And call to implicitly deleted copy constructor. Well, blah, that's no good. So let's try and solve this first one. We're going to go in here, and a lot of you old C++ gurus already know what we're going to do. That's right. We're going to add in the plus operator, and we're going to toggle that. And let's go ahead and make this a little prettier here. Auto indent, and yep, still the same problem. Call to implicitly deleted copy constructor. There's just very little way to get around that. So in the real world, what we would do is we would take this guy along with the new one and then add them together and then return some sort of value. But we just keep bumping heads with this copy constructor. There are some ways around it. This video, we're going to talk about the most bare bones basic way, which I actually do not like. And let's go ahead and toggle that. And we're going to just say private. You're going to see a lot of this in the real world. That's why I wanted to add it. And value. And you guessed it, we are just going to encapsulate some sort of value inside of here. IDE does it for us. Jump back here. And this IDE is so aggressive, it still sometimes will flag that as an error, even if it's commented out. So I'm going to just say, let's see, M1 set value, and let's say 3, and M2 dot set value. I'm just going to pick a random number 5. And this should work as expected when we do something like this. M3 set value. Whoops. Scroll down so we can see what we're doing here. Got a little ahead of myself. And we're going to just say add, and then we want to say M1.value and M2.value. And this should work as expected. But again, it's kind of not the same. It just kind of distracts from what we're trying to do, and it makes life a little bit more messy. Everything works. Let's go ahead and print this out. Let's grab this. And some would argue that we're not even doing it correctly this way because we're not actually adding the classes. We're adding integers, which are encapsulated in the class. And you're 100% correct, to be brutally honest with you. That's why I don't like this way. And I'm going to say value, but with that copy constructor disabled, there's really no way around that, and it's just super, super frustrating. So this section is going to be how to deal with QObjects and generics. We saw in the last video we cannot take a Q object and put it through most templated functions simply because of that copy constructor. But we can do the exact opposite. We can put the generic code inside the Q object because Q objects under the hood are really just C++ classes. So I've got my class, and we haven't really done anything with it yet. Let's go ahead and jump in here, and we're going to, you guessed it, try to play around with this. And if I say, try to make this whole class a template, let's go ahead and try this. Oh, look at that. Might just work, maybe? Let's try and build. Nope. So, yep, invalid use of template name my class without argument list. All right, we could probably try a bunch of other things, but we're gonna have not a good time there. So what I typically do is I'll do something like this, where I'll just put the entire templated function right in the class itself, and then everything just works as expected when we go back to C++ land. So let's go here, and let's add in our includes. And let's just type this out. So I'm going to say my class. And then let's go ahead and go Q info. And let's go my class add, and there it is in all of its glory, 2 and 3. Doesn't really matter what we do here. We can just grab this and let's just throw a couple things in here and watch it work. Let's say 6.34 and 8.12. Why not? Save and run, and as you would expect, everything just works. Now, the interesting bit is if you try to do what we did in the last video, that's right, still going to have this call to implicitly deleted copy constructor in here. There's just very few ways of getting around that. We're going to look at some alternative solutions, but I just wanted to drop a quick note that you can put a template inside of a Q object. Just because that copy constructor is deleted doesn't mean you're forbidden from using templates. It just means it's a little bit more challenging. So if you've watched the last few videos and you've kind of gotten the sense that working with Q objects and templates is dangerous, if not downright impossible, well, you're on the right track. It is actually pretty challenging. You can get around it very simply, very easily, as we're about to demonstrate, but you can actually introduce some really, really dangerous things into your program here. So let's take a look. First off, I've got a my class, which is just a Q object with absolutely nothing in it. It's just a blank class. Just wanted some sort of Q object. And then I have a what I call not Q, which is just a normal C++ object. Now notice how we have set object name and object name. So we have a getter and a setter of object name. If you know anything about Q object, you know that you can do the getter and setter for the object name inside of Q object. So what we're going to do is we're going to make a template where we can pass either one of these, but it's actually pretty dangerous doing so. So here's our main. Now before we continue on, I want to stop and just give a little pause here. Notice how the naming convention, Q list class. Flip over to the Q objects documentation. It says the Q object class is the base class of all Qt objects. That's very misleading. And this is one of the first things people learn about Qt is that Q object is the base class. So they immediately think Q list, Q vector, Q hash, Q, all those templated classes are also inheriting Q object, and they are 100% not. Just because they start with a Q does not mean they're Q object. These are just normal C++ classes that are templated that work with Q object, but are not themselves Q object, and that's where really the confusion comes in here. So in case you're really wondering why you can't do signals and slots to a Q list, that's why. And let's flip over here. All right, let's make our template. And let's say template. And let's call this test object. Why not? go up here, and let's say very, very simple. Now let's go ahead and say x dot set object name very, very simple. Now set object name should be in both of these, and just to double check, there it is. Bang. So let's jump back here. NQ, possibly the coolest variable name of all time. And let's just my class, and then from here we can play with this even further if we felt like it. But it's pretty simplistic what's going on. Grab this. And as long as we didn't screw up the naming convention, everything should compile and run, and we have absolutely zero warnings. The problem we have now is we're assuming this is a QObject because we're using something that QObject has. So if I go like this, build run, program should run just fine. We hand this code off to junior developer. He's going to say, oh, test QObject. So this must be a QObject that I can do something with. And then they try something that's not in this non-Qt class, and boom, problems occur very quickly. So one thing that I like to do, if you're going to work with QObjects inside of a template, is actually test to make sure it is actually a QObject. I know, silly. So we're going to say, if not, and then std, we're going to reach back into the standard library, is base of and then let's go ahead and return. And then sure enough, hello from template, that's our QObject, and then the other one, this not Qt, is not a Qt object. Very simple, very easy to do, and it adds a layer of protection. Again, just because you can do something doesn't mean you should. 99% of the time, this can be simply replaced with this. That's right. Very simple, very easy replacement. No template madness. And it does the exact same thing, and you don't even have to worry about whether or not it's a QObject because the compiler takes care of it for you. Now, this video is a bit of a refresher, and we've talked about this several times already, but just in case you skipped ahead and you skipped all the other videos, you went right to this one, Qt does use templates for some of its classes, for example, QList, but you can very easily create some memory issues and just downright destroy your program. So if you already know how this works, if you already watched other videos, you can safely skip this one. This is just a refresher, or in case you skipped the other ones. So we have a my class, which is very simple, constructor deconstructor, really not anything special in there, just created and destroyed. Just wanted a QObject for us to work with. So what we're going to do next is we're going to go in here and we are going to, you guessed it, play around with QList. So QList, my class, let's call this list. Notice how everything seems to work. All right, well, if we were to do this, what is really the problem based off all the conversations we've had so far? You guessed it, copy constructors disabled in QObject. Oh, super, super frustrating here. So let's actually do something like this. And let's say, Let's be super smart about this. Let's grab this thing, bang, bang, and let's actually do that. Let's call this MC, append, MC. And what do you think is going to happen here? Well, it looks like it worked, or did it? So let's go Q info, list length is what we're looking for here. Save, run, and let's see what happens. All right. Oh, that's right. We didn't even use this thing, and it already blew up our app with 9 errors. Now, let's try and use it and see what happens. It's probably going to give us back the same amount, but yep, same amount. But some of these are just really, really confusing. Use of deleted function. What function? And then it gets into type info and all this. Really, it's the same thing we've been fighting with this whole time. Use of deleted function is use of deleted copy constructor. Oh, man. What a pain. All right, so what we can do, very, very simply, you guessed it, change this to a pointer. Change this to a pointer. And if it feels like I'm really beating this into you, there's a reason for that. It's horrible the way this works. It works that way for a reason. Qt wants to make sure you don't shoot yourself in the foot later when you're trying to, manipulate Q objects and you make a copy of it and then you can't figure out why the signals and slots aren't working and blah, blah, blah. But anyways, my class. All right, let's build this. Now it builds, now it runs, and everything works. Now we have introduced yet another problem into this application. That's right, there's no parent. So, well, how do we get around that? We could try and do something like this, but we end up automatically with no matching constructor, and that's because QList by default is not a QObject. Again, from the last video, very confusing. The QObject class is the base class of all Qt objects except for, drumroll, any templated class. Oh, that is super frustrating. So all your QList, QHash, QVectors, all those, again, just in case you skipped the last few videos, these are not QObjects. These are C++ classes that work with QObject that just happen to start with the letter Q, which makes it super, super confusing. So now we have a problem here. How do we manage that memory? Well, let's call this add item, just to avoid confusion later on. I'm going to go ahead and add item. Now let's say remove item. And I'm going to just, through the magic of copy and paste, again, this is very rudimentary and we probably covered this about 100 billion times so far, but I just want to really drill this into people because I know some of you out there, you know who you are, have a habit of skipping videos and then wondering why things don't work. So I'm joking, but I do get that a lot in my courses where somebody will skip 5 or 6 videos and then send me a private message going, hey, how come this doesn't work? And I'm like, it's on the video you skipped. And I'm going to say length. So it'd probably help if we had an I here. So we're going to remove item from this list at position I. I should actually call this index. That way it's pretty obvious what's going on here. So if index is greater than or equal to the length, we're going to just avoid any sort of issue. Then we're going to say list remove at. And then let's go ahead and remove it at the index. Again, I'm making this more complex than it really needs to be. And some of you are already shouting at your screen because you know what I just did. We're going to say list remove at, and let's say 4. So now I'm going to just make another function all the way up here. Fill list grab this little pasty action going on there. Very, very simple. Just going to say for int I equals 0, i's less than, and we'll say why not 10. And let's actually move this up here. That way we can just reuse this thing. Big fan of code reuse there. All right, so we are super smart. We've got our list. We can add one. We can add a bunch of them. And we can get the length, and then we can remove. And then let's go ahead and make another one called print list. Why not? And let's go ahead and grab this again. And let's go ahead and say for, why not, for each. All right, yes, we need a pointer. Very, very simple here. There we go. Whew. All right, lots of work. We have saved the world. And let's go ahead and finish this program up, and then we can quit for the evening and go home. And then when we save and run, yes, silly me, simple error. Let's fix this. All right, now it should build. We got a good build. We go home for the evening, we come home the next morning, we run the application, and wait a minute. Did you see what happened here? Why aren't these being deleted? Oh, right. Oh no. We didn't delete the memory. So now we've got a massive memory leak on top of this. Super frustrating. Okay, so in short, when we remove an item, so let's just demonstrate in case we lost anybody here. We add the item, we see the created, we never see the destroyed, meaning that thing lives out in memory. If we go ahead and remove the item, let's remove it at position 0, you can see, well, we have one in there, and if we print list, there's absolutely nothing, so it's still there. We never saw that destroyed. It's still out in memory somewhere. Super, super frustrating. So that's right. Because we're working with pointers, we have to, you guessed it, get rid of this bad boy. So we're going to say list remove at, but before we do that, you guessed it, we've got to get a pointer to it. And let's go ahead and say my class equals now that we have this pointer, we can remove it from the list, and then bang. So in short, we have to manage our memory, which becomes very, very cumbersome. Now we have our created and destroyed, but what if we did something like this? Now, again, we've only destroyed one of them. All of these are still hanging out in memory land. We want a simple, easy way of getting rid of those. You guessed it. QDelete all. Going to hand it our list and let Qt handle the memory for us. Now we've created and destroyed all of them. Again, a bit rudimentary. I just want to throw this out there in case somebody skipped a bunch of the videos and gone straight into this section. They understand that whenever you try to get around that copy constructor using a pointer, you are now responsible for that memory. And as we all know in C++ land, if you don't manage your memory, bad things will happen very quickly. Okay, so the last few videos, we've really outlined some challenges with working with Qt and templates, and specifically Qt templated classes. Now we need to actually understand that if we're going to get around that disable copy constructor in QObject by using pointers, and we have to manage our own memory, there is a better way, and it's called a shared pointer. We've worked with this before. It's super easy to use, and it works beautifully with templated classes. So let's go ahead and put some includes in here. QDebug, QSharedPointer, and myClass. myClass, again, is just a blank class that has constructed and destroyed. So we can see actually its full life cycle here. All right, let's jump in here. And let's actually say void add items. I should say, yeah, add items. Got a little ahead of myself there. QList. And this is where things get a little bit confusing. You notice how I'm putting those brackets in there immediately. That way I don't lose track of where I am, because I'm not the best at this. And I'm going to say QSharedPointer, and then put the brackets in again. You get this double arrow. That confuses some people. Don't let it. And myClass list. So it has a very horrible looking parameter there, but it's actually very, very simple. We're just making a QList filled with QSharedPointers that uses myClass. Now, because we're using QSharedPointer, we're telling Qt, hey, you track the memory because I'm busy and I don't want to mess around with it. Let's go ahead and grab this, and then we can just simply say and then we can say myClass make sure that does not have a parent, make it very painfully obvious that it does not have a parent. And we're going to say myClass set object name. And let's go ahead and give this some sort of super special snazzy name. For example, myClass, and then whatever number we're currently on, and then we're just going to list append this. Now we want to make sure we encapsulate this or wrap this inside of a QSharedPointer. So I'm going to say QSharedPointer, and let's go ahead and say myClass, and give it our instance there, myClass. So really, what have we done here? My gosh, what have we done? So very simple. We have a list. The list, instead of pointers, has QSharedPointer, which wraps around the pointer to our class, so we don't have to manage that memory. Looks really confusing if you're from newbie land, but seasoned veterans, especially you old C++ gurus, are going to know exactly what that is. Now we can go ahead and let's just play around with this just a little bit here. So I want to say void test list. Just going to make a function so we can see Qt do that automatic memory management for us. We don't want to have to play around with it. Save just a moment of typing. I'm going to grab this. Say this is our list. And I'm going to go ahead and say add items. Hand it our list. Add those items in, and then we're going to say list dot, and I want to remove at, let's say 2. Why not? Gonna paste something in super quick. So I'm just gonna say QInfo count, whatever that is, and then print that out again, just so we can see that it was actually removed. I'm gonna do a for each, and this is where sometimes people get a little confused. Again, super simple. You just need the type, item, and then we need our container, which is the list. If it seems like I'm copying and pasting a lot within my own code, I am for a reason, and it is because you can very easily misspell something like that, and then you have all sorts of weird errors. I can't even say it. You'll have all sort of weird errors that you'll have to figure out here. So 99% of the time the IDE will catch them, but once in a while you have that one where you just sit there for 10 whole minutes looking at your screen going, what the hell just happened? So, whoops, not object cast, object name. And then we're going to go ahead and move this down here. So really, what are we doing here? We're just making our list of Q-shared pointers which hold a pointer to the My class. We're going to fill that list up with 10 items, and then we're going to print it out. I should say print out the length. We're going to remove @2. This is the interesting bit here. Then we're just going to print out the object name for each one, print out the count, and then it's going to exit. And you're going to see something beautiful happen. Q-shared pointer is going to come to the rescue and remove all of that memory for us. Simple to use, simple to understand, and most importantly, it takes us out of memory debugging. Voila! So we have a bunch of constructed count, and then we removed one, and then sure enough, we can see it goes 0, 1, 3 because we removed that other one. We have a count of 9 because we removed it, and the rest are destroyed automatically for us. So if you're ever concerned about putting a pointer in a QList, don't. You have plenty and plenty of tools at your disposal, whether you do QDeleteAll or you make it a list of Q-shared pointers. It doesn't really matter either way, as long as you just remember to take care of that memory. When in doubt, I almost always prefer the Q-shared pointer, simply because I don't have to worry about forgetting to do the QDeleteAll.